Okay, so I'm going to introduce you to your internal assessment. And here I hope that you'll learn how to do better investigations as well as do well on your IA. So just to give you an overview of what IB expects for your internal assessment. It will be 25% of your overall grade. So this is an important project, taking 10 hours of your work. So you can really take a lot of time on it and get quite a lot of marks where you don't need to memorize things as you will for the exam. You're identifying an ESS issue, any kind of issue that's connected to environmental science, but you want to focus your research question quite specifically. You need to develop your own method so that you can get data. And you need to put this into some context of how this relates to the bigger environmental issues that we face in our world. And you can go back on this PowerPoint and review there the way that the marks are broken up. So we're just going to look at some of these aspects today, identifying the context. This is worth 6 marks. So really what we want to do here is to put the research question into an interesting topic. If I said my investigation is going to look at water temperatures of 2 different ponds at Hogwarts School, there I'm going to get data, but it's not very interesting. Nobody cares about it, okay? What I have to do in identifying the context is to say why it's important. So in warm water, we get less dissolved oxygen, and therefore there's less oxygen for different organisms. So I would expect that in warm water, biodiversity would be quite low. And at this school, perhaps, we've got an inlet and maybe the water from the heating system is coming out into that pond and warming it up. And maybe that's lowering the biodiversity. So if I measure the water temperature in that pond and then compare it to another pond on the grounds, and perhaps I collect some invertebrates from the water and look at the biodiversity of the 2 ponds. Now I've got something quite interesting because I'm saying what's the impact of this warmer water on the biodiversity. More biodiversity, more stability, and maybe the school is helping create an unstable ecosystem. It's relevant, and I've identified the context for why I want to look at water temperature in the 2 ponds. So how do you start thinking about this? How do you get your context or your research question? At first, it might be quite hard, but as you're going through your lessons, keep a section of your notebook for recording any issues that are of interest to you. Okay, during your lessons, you can also listen to podcasts like Radiolab and watch documentaries like Planet Earth and be reading environmental magazines like Down to Earth, which is a great Indian magazine, National Geographic, and some stuff in New Scientist. And I will put links to all those resources on this webpage. Okay, the next aspect is planning, and here it's not just that you're doing the planning, but you have to write up the plan in your report. So you should really make it very clear so that anyone can repeat your study exactly as you carried it out. You need to explain why you've chosen the methods you've described, like why are you using a ruler instead of a thermometer? What's the reason for the tools that you've chosen and the method you've chosen? And you must consider any risks or ethical issues. And it's a good idea that even if these are minimal, even if you're just doing something that's very simple like a survey, you do consider them. Is there any way that there could be some harm? Have you thought about it? And show the examiner that you have given that some thought. So the biggest problem that people face with writing their planning is they don't give enough detail. So let's look at an example here. If I asked you to make lasagna, here's the ingredients: flour and water and mushrooms and tomato sauce. And the method, I say make the lasagna noodles. Well, you don't have a clue how to make lasagna noodles, unless perhaps you're an expert pasta chef. And then it says take the lasagna noodles and layer them with the vegetable mixture. Well, I haven't explained how to make the vegetable mixture. And place the cheese on top of each layer. Well, I haven't listed cheese as an ingredient. And then cook it at what temperature, for how long. So you need to include details so that somebody can repeat this. Somebody wants to make lasagna, and hopefully many people if you're publishing your recipe. You need to make it very, very clear how you're going to do your experiment. Don't skip steps. Tell them everything, even if it's obvious to you. Okay, your data that you collect must be reliable. By reliable, we mean that you've collected it many times and you get the same result every single time. So for your internal assessment, you must collect your data 5 times at minimum. That means you're repeating any experiment you do 5 times. You must describe how you are going to make it reliable when you write your plan. And you must collect sufficient data in order to see a pattern. If I give some seeds no water and other seeds water, well, the seeds I give no water to won't grow, and the ones that I give water to might grow. And in the end, I definitely don't have anything that tells me about the effect of water on seedling growth. So you'd need to have at least 5 changes in the variable that you're measuring. So like 1 milliliter of water, 2 milliliters, 3 milliliters, 4 milliliters, 5 milliliters, and be giving that amount of water to your seedlings, and as I said before, repeating that whole thing 5 times to make it reliable. The way that you're going to show your examiner or to show your teacher that you're ready to start your experiment is to produce a data table. So you want to start this before you start collecting data, and then that gives you a space to collect it. So in the first column, you're going to put the variable you're changing. So in this case, in this example, it's the amount of water. And notice that the water goes up in even increments. So it goes up by 5 milliliters to 10 milliliters, then 15. It doesn't go up to 12 and then 17 and then 25. It goes up by 5s. And you must make your independent variable, the one you're changing, go up in even increments. In the second column then, you're going to record your data. For example, plant growth in centimeters. And notice that I have included my units. Just like I needed to know how long to cook the lasagna, I also need to know how I'm measuring the plant, how I'm measuring the water, what units am I using. Now, as we said, you must repeat your experiment 5 times in order to make it reliable. So your data table won't look exactly like this. It will look like this. Each of those columns then under the data I will collect is a separate data collection event. So you'll collect it 5 times for all the 5 mils. Okay, you can come back and review this. It's a list of things to make sure your tables are clear. And as you'll see later on, communication is really important, and you will get graded on that as well. But things like making sure you've used a ruler, drawn it neatly, given headings. You must also make sure that your experiment is fair, and this means that if you're doing an experiment, because not all your investigations may be experiments, but if you are doing an experiment, that you keep everything the same except for the variables you're measuring. So let's look at an example. You want to know about the distribution of crab holes on a beach. Are they all bunched together or are they evenly spaced out? The variables that you're measuring is the distribution of crab holes, so that's going to vary. And you take your measurements at the same time each day. So why do you take your measurements at the same time each day? Because perhaps the time of day could affect whether the crabs have built their holes or not. Perhaps where the tide is, the tide comes up and that's going to affect your results. And you make your measurements on the same beach. You don't switch to another beach because it was more convenient to go there, because perhaps that beach is facing in a different direction, perhaps the sand particle size is different. You need to control for all these variables to make it a fair experiment. Now, as I said, you've got communication marks, just 3 marks, but again, that's important. That's 10% of your overall grade. You need to have it well structured and well organized. You need to make sure you use some of the ESS vocabulary and don't make it too wordy. There is a word count on this report of 2,250 words, so you can't go over it. And the report needs to be logical. It needs to make sense. It needs to follow on with like what you started with, what you did next, what were your results. Make it a story. So how do you get all 3 points? The best thing to do is start early and then you can take your time. If you're rushing to do this, that's where you start to lose your clarity and the whole report will become incoherent. Now I'm going to leave it there. There are 3 more sections that you will have to address in your report. They are your results, analysis, and conclusion. So what you found out, for another 6 marks. You need to discuss this then in the context of what you were researching. You know, how does this relate to the big picture? What was the context you set it in at the beginning? And what went well and what could you do better? And then the applications. How could this research be useful in the world? How could this research be useful in your school? So I will give you another presentation later on. For now, just be thinking about what's your question going to be, what's your context going to be, and how will you plan it?